Okay everyone, so in this lecture video what I'm going to be going through is a more detailed view into the synovial joint. So in the last video you watched, we talked about how there are different joint types and different classifications. So talking about synarthroses, amphiarthroses, and in this video looking at diarthroses. So a diarthrosis is an example of a synovial joint. You get a joint where you have a lot of different motion. Okay, so let's define what those are. So a synovial joint is just a complex joint. Okay, it's complex in that it's bound by a particular layer of tissue around the joint or the articulation where the two bones meet. There's a layer of fluid that's in there, right? And there's often other things like cartilage and things that provide additional cushion for that particular joint. So the reason why we say it's a complex joint compared to the other ones is because there is this interplay of different tissues that are going to be involved with any kind of movement at a synovial joint. Okay, so when we're talking about synovial joints and synovial fluid, this is a type of membrane, right? Kind of a different layer that's going around or covering something to provide a layer of protection. Okay, so let's talk about the broad structure of a synovial joint, and I'll go through a diagram of that, again, a part of the pieces that you have to look at a little bit later. But when we're talking about a synovial joint, we're generally going to find those at the end of long bones. Okay, so synovial joints are found between your femur and your tibia, right? Like in your knee. You have them in your elbow, you have them in your shoulder, right? If you look at my hand, all of these flexion points right here, these are all examples of where there is some kind of synarthrosis, or sorry, diarthrosis. There's going to be some kind of synovial joint there, okay? With these things, there is going to be articular cartilage that's available to provide additional support, again, to prevent the bones from having bone-to-bone contact. And again, it's not great if you have bones rubbing against each other because there's a lot of nerves that are embedded inside of your bones, so it'd be extremely painful, right? The cartilage is there to provide not only support in that you are from friction from the two bones rubbing together, but it also provides support in that it lowers the impact or the feeling of different forces on your bones. So by lowering the transfer of force, right, its main job is help cushion and make so that you don't feel the full impact of a lot of things, right? As you get older, that cartilage can start to wear away, or individuals who are, say, extreme athletes and things like that might end up experiencing some damage to that cartilage over time that can lead to more issues. If you have osteopenia, if you're osteoporotic, all right, that's another example where the articular cartilage might also deteriorate. It's not getting replaced enough, not getting replaced often enough, and can lead to other issues with bone-to-bone contact. So this might be like if someone's experiencing extreme amounts of this, they might have to have like a knee replacement or synovial joint replacement. Okay, when we're talking about articular surfaces like these with the synovial joints, again, you have this fibrous capsule that surrounds it. Okay, I like to think of it as like if you say put your foot inside of a sock, the sock is that capsule that's surrounding it. Okay, it surrounds each of the joints, right, and protects it with like putting a layer of fluid around it. Okay, so that layer of fluid not only helps lubricate the joint, right, where you have the articular cartilage, but it's also there to help with, again, absorbing forces, provide additional protection. Okay. With these joint capsules surrounding each of the joints, right, you're going to experiencing a chance for where you might have some damage or you might have some leakage. Sometimes individuals that have, say, knee damage or tear their synovial joint fibers, the membrane around it, right, you can actually have leakage of that into your body and it can swell quite a bit. Okay, sometimes that happens when you damage joints. You may not break them, but you may puncture it, you may tear it, right, and you may get lots and lots of swelling, especially those synovial joints. So like I said before, complex joints like your knees and shoulders often have other features like meniscuses, fat pads, and other things to help reduce friction. Those joints that have kind of extreme amounts of impact that you're dealing with, like your knees, for example, right? You're not only having to deal with the forces of walking, but you're also having to support all of the body mass that's on top of the knees as you're walking. So again, you have to be able to have additional cushion there to help support that. Okay, there are other features that are provided inside of a joint. Like first is the ligaments, right? Obviously, if you have two bones coming together, there is a ligament that's putting those together. Again, ligaments are connective tissue that can put bones together, hold them together. And that connection point is going to be present in any kind of synovial joint. Same as with the with our amphiarthroses, and the same with our non-moving joints. Synarthroses. So both of those are examples where you're going to have ligaments that are holding those bones together. Okay. The last thing that you have is a bursa. So a bursa in anatomy is just a pocket of fluid. And generally this is the cushion that surrounded the particular part of that joint. Okay. So let's just look at a diagrammatic view of what all those pieces are. Again, the cartilage, the joint capsule, the fluid, the ligaments, the bursa, all of that stuff. Okay. So here I have a drawing or a diagrammatic view of a couple different joints. The first one is just your standard basic synovial joint, like what you might see in your finger. Here's an example of the knee. Again, some other things that might exist beyond that. So with all of these joints, right, you're going to have the bone, right? The bone is going to be connecting with these two places where there's a piece of articular cartilage between those. So again, any articular cartilage is going to be to those. Generally, it's hyaline cartilage, again, there that's providing a lot of extra support with really dense cartilaginous structure made of lots and lots of collagen fibers. Okay, you have the synovial membrane, again, the membrane that's around this area, this pocket of fluid, right, that has your synovial membrane, and then you're going to have your fluid that's in there, synovial fluid. Okay, if we look at the knee, again, there's additional things here, like the fat pad in the front underneath your patella. You can actually feel that. If you do a full extension of your knee, you can kind of press on the side, and you can feel there's this kind of squishy. Between those, again, because these are more complex joints in the knee, you're going to have a meniscus between those. Again, those intercartilaginous intercapsular ligaments, right? Meniscus, again, all of those things that are going to be, again, there for additional support, especially in your knees and shoulders. The bursa here, again, is that pocket of fluid that's providing additional support. That bursa, like for example, in your knee, is actually behind your patella on top of your femur, just so that you are not having the patella run directly over that. Okay. So again, this main structure here, what I'm interested or really care for you guys to know is that structurally these are very complex, right? There's a lot of things going on. Okay. So let's talk about the function of a synovial joint. Okay, functionally a synovial joint is going to provide the widest range of motion. Okay, so since it's providing a very, very wide range of motion, it is by far the weakest of the joints. Okay, and that means that most of the injuries you're going to experience if you're, say, playing a sport or even just in your day-to-day life is going to occur at these joints. These joints generally experience a lot more forces, they experience a lot more use than the rest of your joints in your body. And because of this, there's a lot of different stuff that's going to go down, right? They're going to be damaged a lot. If you go and talk to any kind of sports medicine individual, probably the two areas that they're dealing with the most in terms of injuries are with your shoulders and your knees. Elbows maybe is another example. Hands is another area where there's actually quite a bit of damage and injury because, again, there's an extremely wide range of motion that occurs in your hands, and you're using your hands for almost everything. Okay? So because these synovial joints are so vital for our overall wide range of motion, this is what we're going to focus on in terms of the types of motion that we're observing. Okay, we're really interested in looking at the motion of synovial joints. So, like I said, these are the weakest of the joints, right? They lead to the most injuries of joints overall. Okay, but what we're going to be looking at is just kind of identifying the main types of structural classifications of joints. So the 6 types that we're most interested in, and I'll talk about examples of those as we start moving into the different types of motion that we get to here in a little bit. Okay, so if you've got more questions, let me know.